right, I think everybody are in, at least most of them. We can get started. All right, what did we discuss in our last session? I'm sharing my screen. It's visible, right? Okay. Okay. What did we discuss in our last session? Yeah. Minicart. And what did we discuss in this? Now I'm sharing my screen. Anybody? Correct. Correct. That's right. Anything about the cache layer? That's right. That's true. All right. Fine. Let's go through some theory, okay, about why we need high availability. I believe we discussed this a little bit, right? Why we need high availability. I think we also discussed on why we need read replicas, right? Okay, we'll go through it again. Doesn't hurt. Fine. So it's in the document that I've shared. It's available with you, right? Today, we will discuss about uh, high availability, why we need high availability in a database, what we mean by high availability. We'll discuss that. We'll discuss about read replica, right? We'll also discuss about elastic cache as to why we need them. Number one. Number two, today we will also discuss about Aurora cluster. Okay, AWS Aurora cluster or cluster architecture. It's nothing but another database. So maybe let me go into RDS, okay, database, create database full configuration. We'll talk about Aurora, right? Another database. As you can see, okay, it doesn't mention here. Aurora is an database service provided by Amazon. Okay, just like there are SQL services provided by Microsoft, and it's called as Microsoft SQL. SQL services provided by Oracle, and it's called as Oracle Server. SQL services provided by MariaDB, and it's called as MariaDB SQL Service. Similarly, Amazon is also providing SQL services, and it's called as Aurora. We have a lab, right? So we have a lab on this. We'll discuss that today. I think we'll have enough time for that. It's a quick and small lab. Fine. Let's get started. The time now is 9 o'clock and 9 minutes. All right. Database, right? Um, we saw three different components in database, right? There is stand-only database, and then there is high availability database, right? And then there is read replica. Right? So there is stand-only database right here, just the primary instance, just a single node, nothing much. And then there is high availability. Yeah, there is a primary and a secondary. And then there is read replicas. Okay, there is an write read endpoint. Here there is no standby. Standbys have become read endpoints. Like, why to waste the resource but just keeping it as a standby and never used throughout the year, right? So we're making them as read replica endpoints. So these are the major three types we discussed. And then there is also elastic cache we discussed, right? So all of them come under database only. So why these many components? I mean, is it not enough? We just have one like this and it will work. Yes, it will work, but it will not effectively work. Okay, so that's why we need multiple components. So why high availability? We need high availability because when primary fails, which it will fail, everything in cloud, yes, it will fail, right? So when primary fails, right, the DB service can automatically switch to the standby with no human action required. So that's why we need high availability. So anytime during scale or anytime the DB crashes, which can crash anytime, right? The application will continue to work without any downtime, without any human action. That's why we need high availability. Why do we need high availability? High availability is needed because without an high available service, meaning without the secondary, right? Um, Downtime can be up to many hours. Imagine we only had a single server and that failed. Imagine we only had a single database that failed. Bringing up a new database could take like 4 hours. So it can take from minutes to hours. And then with high availability, if we have high availability, the downtime will be less than 2 minutes. That's what happened, right? Actually, we did not feel at all, right? We rebooted our primary, the connection got shifted to secondary. We did not feel it, right? The application was working as usual, right? Why do we need high availability? We need high availability because it kind of gives protection against the AZ or availability zone failure. In North Virginia, right, there are 6 availability zones. We know that. In Mumbai region, there are 3 availability zones. We know that. If any one of the availability zones fail, I mean, the entire availability zone, that's also possible due to some power outage, some network issue, the entire availability zone can fail. In that case, our DB service will still run because we have enabled high availability. Our primary will be in one availability zone, secondary will be in another availability zone, and even if one availability zone fails, it's going to work smoothly on the secondary availability zone. Why do we need high availability? Because it handles infrastructure failures transparently. Uh, if there is a disk failure, if there's a host failure, if it is an OS failure in the database, right? Because we have a standby, the application switches to the secondary, and it's kind of very transparent, right? The users will not see it, right? No data loss because we have high availability. Data is written to the primary and is returned to the standby as well. So no data loss occurs when there is an failover. Okay. Why do we need high availability? It improves application reliability. Okay. No code change is required. We did not like manually point it to the secondary, right? We pointed to one endpoint. That endpoint was handling both primary and secondary. When primary is active, it sends traffic to primary. When secondary is active, it sends traffic to secondary. Talk about maintenance, right? Let's say we need to do some maintenance in our database. We need to do some patch update in our database, right? So how do we do it? If it is just one server, right? We'll have to bring down the server and then bring up the server. There, it will create a downtime. But if we have high availability, I can do patch update on the secondary first, right? Bring it with the bring it up with the current patch, switch traffic to the secondary, which will now become primary, and my old primary, which is now secondary, I can now do patch update on that. No issues. Nobody will see a downtime. Why do we need high availability? Is needed for production systems. Yeah, there could be 3 or 4 environments in a project, right? There could be a development environment where development team will work on the server. There will be a testing environment where testing team will work on the application hosted in those servers. And then there could be production environment where it's really the end customers. It's the rest of the world, right? People accessing application through that. So the last one is the production application. So the dev environment, QA environment can survive without an high available server because there'll be just 10 or 15 people using those applications, using those servers. But production, there could be like thousands and 10,000s and lakhs of people using the production application. It cannot go down. It needs an high available database backing it up. So why do we need high availability? It prevents single point of failure. And why do we need high availability? Because if our business needs to run continuously without any downtime, it needs an high available uh, database backing it up. So that's why we need high availability. Okay. Now let's talk about read replica. Now let's talk about read replica. Why do we need read replica? This part, right? So why do we need read replica? We need read replica because there are yes, it's just one database that we are accessing. Maybe I'll use my pen here. Okay, it's just one database that we are trying to access. Let's say this is my EC2 instance, right? It's one database that we are accessing, but there could be two types of actions. One is the read action, right? And then the write action, right? Read action is basically saving the data. Excuse me. A write action is basically saving the data, and read action is basically reading the data. This is in, right? This is out, but still the same database, two different types of action. So when we have just one database, what's going to happen is there's going to be a tug of war between the read action and the write action. Who kind of takes priority? Okay. So when we have like 10 users, fine, everything is fine. The CPU is just like 20 percentage being utilized. Everything works like a charm. But when we grow up to 100 users, the CPU goes to 98 percentage. Now there is a real war between read and write. Now who's going to take priority? By default, databases, right? They take write as priority because that's data in, and if we lose it, right? If we drop a write, if we did not write, right, the data will get lost. So it kind of gives priority to writes, but reads, right? Data is anyway here. If somebody's not able to read, they can refresh it again and they'll be able to see the data again. But unlike write, right, if somebody clicks on submit, right, and if that data is not able to submit it, it's very less likely that that person will try to submit again. That person will get fed up and leave. At least I would do that. All right. Um, so uh, that person will not be able to one more time write the data, and who's losing? It's the company that's losing. We cannot get the write happening there. Fine. But you know what? In real time, most of the applications are read type, which means that when write takes priority, somebody is trying to read. If write is taking priority, there are chances that these reads will fail. This will also create an dissatisfaction with the customer who's trying to read the data. So, what's the solution to solve this tug of war between read and write? Better provide them with another node. Sorry, yeah, right here. So better provide them with another node, call this read node and call this write node. So this is how we solve the tug of war between the read and write. All the reads happen here, all the writes will happen here. So there is never a race between read and write. And like I said, 90% of the applications are a read type. So why do we need a read replica? We need read replica because of so the application can perform better. Like I said, 90% of them are read type applications. Okay, and we need to serve that. So it provides better application performance by having a separate read node. Why do we need a read node? We need read node so to scale horizontally. We discussed about horizontal scaling and vertical scaling, right? Vertical scaling is vertical scaling. This is horizontal scaling, right? Vertical, horizontal. Vertical scaling is there is one database. As time go by, I need more space, more CPU. What do? I scrap it, make it a bigger database. Over time, I need more. What do? I scrap it, make it a bigger database. So this is vertical scaling. What is horizontal scaling? I have one server. Over the time, I need more capacity. I add another one. Over time, I need even more. I add another one. So this is horizontal scaling, right? By having read replicas, right? I can horizontally scale my database. Horizontal scaling is always cheap, okay? Because I can add node and anytime I don't need a node, I can simply delete it. My application is still going to work. But with vertical scaling, right? You start small, you grow big. And then when you want to shrink back, right? It's sometimes not possible. So sometimes you will kind of end up keeping this big database, even though you don't need it at a later point. Okay. So vertical scaling, most of the time it's costly. Horizontal scaling is cheap because you have that scaling out and scaling in option in horizontal scaling. Right. So horizontal scaling, I can add more replicas to it and then shrink back when I need it. So that's possible only through replica. So I have a primary, and when I need uh, replicas and more replicas, when the read load is increasing, right? I can add one replica. If that's not enough, I can add another replica. If that's not enough, I can add another replica. And when I don't need them, I can like delete them and come back to normal. Okay. So why do we need a read replica? Next thing, because we're not hitting the primary. Assume this is primary, right? We're not like overloading the primary with all our read requests. Our read requests are this is primary. So only the write requests come here. All the read requests, right? They go to these additional nodes. Okay. So this actually reduces the load on the primary DB, which is like preventing the DB. Less likely is your primary DB going to go down. Again, why do we need a read replica? It kind of increases the user experience or gives a better user experience. Why do we need read replica? It enables reporting and analytics. The reporting analytics workload are big. They kind of hang the server. What do I mean by that? Okay. Let's say there is a database, okay, and there is a reporting team, and there is an BI tools team. BI tools is business intelligence tools. Okay. Teams that use dashboards or create dashboards. Okay, create charts. Okay, create dashboards, right? Create dashboards, and the data for this dashboard is actually fed from the database. Okay. Reporting team wants to run analytics. Okay, what was the performance? How many sales did we do last month? So they basically will have to kind of scan the whole database and take a report out of it. That's a reporting team. And then there is, a read, and then there is normal write, right? But these are just transactions. Okay. Small amount of data gets in and small amount of data gets out. But reporting, right? You kind of scan the whole database, right? And you kind of hogging the database. Same for business intelligence tools. You're kind of scanning the whole database, hogging the whole database. If I only have, yeah, if I only have one database, right? Again, there's a tug of war between read, write, reporting, and BI tools. But if I have read replica, right? This is my writer node. I can create one replica node and give it for the reporting team. I can create this is my replica one. I can create another replica two, and give it to the BI team. Okay, one moment, please. All right. So I can give it to the BI team, and this will not impact the productions. That's why we need read replica. Okay. Why do we need read replica? Similarly, like I giving an um, endpoint to different teams, I can create an endpoint for different countries. My primary can be in US. My primary database can be in the US. Primary database can be in the US. Okay, and let's say I have teams in Africa. I have teams in India. Let's say that. All right. I can actually run a miniature in Africa and miniature in India. Okay, that's used only for read traffic. Nobody's going to write anything from India. Nobody's going to write anything from Africa. All the writes happen in the US, but I can kind of ship a small part of the application, a miniature of the application, run my environment in Africa and India. So all the Indian users, right? They hit Indian web server, they hit the Indian read replica of the database, and they can like handle the traffic locally. And any writes that happen here, right? They kind of get synced with the database in India. So these connections, right? They don't have to travel all the way from India to US and go back from India, go back from US to India. Geo distribution. That's called as geo distribution replication. That's also possible. Okay. For what other reasons do I need a read replica? I need read replica to support microservices. We'll talk about microservices in the upcoming sessions. At that time, you'll understand. For what other reasons do I need a read replica? I can, at a later point, right? It's a feature. At a later point, the read replica can actually be promoted as an primary. Let's say I start with master node or primary node, and then I create a read replica. Okay, this is for BI tools team. Wait. Okay, tools team. And let's say this is for um, reporting team. Okay, reporting. And let's say at a later point, right, the BI tools team, they're saying that, well, we want to work as a standalone team. So, next month onwards, we need a primary database. We just don't need a read replica. At that point, what we can do is we can break this link, okay, break this link, and then make this an primary database for the BI tools team. Anyway, they have the data available there, right? As of now, it's working as a slave node because it's in link with the primary. So at a later point, I can simply break this link and break this slave mode and make this a primary. The data is there anyway. So this will become a primary database for the BI tools team. That's also possible. At a later point, I can promote the replica to primary if there is a need. Okay. Finally, why do we need read replica? We need read replica because it's cost effective. Okay. A huge database and vertical scaling, right? That's expensive, but horizontal scaling is cheaper. Like I mentioned, I can adjust the size based on the need. Okay. All right. Any questions so far? Anyone? Next, we're going to talk about Elastic Cache, and then we're going to talk about Aurora. So, any questions, anyone so far? Okay, in that case, I have some questions for you. All right. Uh, anybody can answer this, right? High availability. Just give me, uh, we discussed 10 different things, right? Just give me 1 point. Why do we need high availability in a database? Just 1 point. Anybody can choose to answer. Excellent. Yes. Excellent. Yes. That's why we need high availability. Wonderful. Thank you. Uh, Next one. Why do we need a read replica? Just tell me one reason why we need read replica. Sorry, say it again, please. Exactly. To improve, most of the applications are read type applications, right? And for us to improve the performance of the application, we need a read replica. Wonderful. Fine. Let's talk about Elastic Cache, and then we'll, get to discuss about Aurora. Time now is 9:32. Fine. Elastic Cache. Yeah, so it's this piece here, Elastic Cache. Why do we need Elastic Cache? Okay. Instead of we hitting the database every time, right? Every time we hit the database, that's taking up CPU, that's taking up RAM. Now we're occupying some space there, right? So every time we're hitting the database, and every time we're hitting the database, we again there is a tug of war between write and read, right? So instead of hitting the database and participating in the write and read, if I if I know that it's going to be the same output, why bother kind of read from the database? Okay, so it's like this. Okay. In our case, we were looking at trending report, right? Trending report, it's a read. So it was getting read from replica. Okay. So instead of like reading the same trending report again and again from the replica, I can read it once, okay, and then save it in cache. So from next time onwards, when I want to read, especially the trending report, I don't have to go to read replica and read them. I can simply read it from the elastic cache. Okay, so again, there's a tug of war between the read and trending report, right? So I'm breaking that tug of war by providing a separate database for cache for the trending report. So this is again, one more time, uh, improve the performance of the application. Okay. So why do we need Elastic Cache? Because it provides microsecond, ultra fast data access. No calculation is involved. Calculation is already done, and I've taken the report. I've saved it in Elastic Cache, and I'm directly reading it from there. Why do we need Elastic Cache? Because, like I said, most of the applications are, 80 to 90% of the applications are uh, read. Okay, and a cache is nothing but repeatedly reading the same thing again and again. So that I can offload from the read node and save it in a separate node, and that's how I handle a read heavy workload. Why do I need elastic cache? It improves user experience. The wait time is improved. Why do we need um, elastic cache or caching? Anytime the traffic is high, right, and the trending people looking at trending will also go high. So instead of hitting the database hard by just reading the trending data again and again, so only for that trending data, I'm providing a separate database that's Elastic Cache. Why do we need cache? Frequently accessed data, which is called as the hot data, I can store them separately and handle that traffic separately. Again, why do we need elastic cache? Leaderboards, right? If I need to look at leaderboards, I can move them to elastic cache. Now, will it not work in a single database? Yes, it will work in a single database, but it's going to take a toll on the performance of the application. It's going to work, but the performance is going to be poor. So to improve the performance, we are providing these additional nodes. Okay, session management, we'll talk about that later. Decoupling the application from database. So first we decoupled the write from read, right? For read, we gave a separate node. For write, we gave a separate node. Now for caching, we're giving a separate node. So this is how we decouple the application from the database by providing different nodes. And lastly, why do we need elastic cache? Introducing caching in our application actually helps with cost optimization. Otherwise, what do we need to do? We need to scale the database. Right? Once you scale the database, it's not possible to, scale down as and when we like. That's not possible. So we provide elastic cache. At a later point, if we don't need elastic cache, just remove it. If we need to scale elastic cache, that's handled separately. If we need to scale down elastic cache, that's handled separately. We're not like playing with the database anymore. Okay, we provided different nodes. Fine. So that's about elastic cache. Now, let's talk about Aurora. Okay, in the meantime, right, I thought these topics are kind of important. Yeah. So let me go to Naukri. So far, we discussed multiple topics, right? AWS, IAM, IAM. Okay, we're targeting cloud engineer type of jobs, right? Yeah. So cloud in AWS IAM, we discussed AWS IAM in the very beginning. That's needed in cloud engineer jobs, right? 1 to 5, 1 to 6 years kind of jobs. It's needed. RDS, AWS RDS. That's what we're discussing as of now. Yeah, that's needed in infrastructure specialist jobs, cloud architect jobs, and support engineer jobs. Right? Let me make it three, maybe. Yeah, platform engineer jobs, DevOps engineer jobs. RDS is a needed skill. Yeah, and then replica, RDS replica. Let's see if it pulls out AWS. Okay, application support engineers. Uh, we need to have knowledge about elastic cache. We support engineers, like how to provision them, how to manage them, how to start them, how to terminate them, how to provide access to them. What are the different platforms? What are the different elastic cache types available? Stuff like that. We need to know all that to be a successful support engineer, cloud support engineer, on and on. Right. Next, Aurora. We're going to talk about Aurora now, right? Aurora is an important skill as well. A lot of companies are moving to AWS Aurora because of its attractive features. We're going to talk about that in some time. AWS data engineers, they need that skill. Cloud administrators need that skill. Cloud operation associates need that skill. Developers need that skill. On and on. So it's what I'm saying. It's being widely used. That's what I'm saying. All right. So come back to the console database, create database, Aurora, right? We have Aurora MySQL compatible. Aurora is Postgres SQL compatible, all right? And I said Aurora is Amazon's version of SQL database. Okay, let's look at some theory and then we'll come back and do the lab. So this would be what lab? 16, right? Okay. We'll talk about 10 things we need to know about Aurora in some time. We'll talk about that. Okay. What's Aurora? It's just like, to the most part, right? It's just like other database, but it has got two main important features that differentiates it from other databases. Okay. Two things. One is, I think if you understand that, right, just two things. If you understand that, you've understood Aurora most part. So what's the two important feature that differentiate Aurora from other database is scaling. Okay. Database, right? In normal database. Let's say this is normal database and we have Aurora here. Aurora, AU. Okay. This is a normal database. So anytime I need to scale this database in terms of CPU and storage, right? So what do? Anytime I need to scale my normal database in terms of CPU and storage, I basically make it bigger and bigger, right? So this is scaling vertically, normal database. Okay. But with Aurora, right, it's set up in such a way that and scaling this way, scaling vertically requires a reboot, right? I need to change the instance type and then reboot, and then only then this will become an bigger database, right? But with Aurora, the internal architecture is different in such a way that it can actually auto scale. Okay, it can actually auto scale. We'll talk about that today. Okay, so CPU scaling with a normal database, it's vertical scaling and it requires a reboot. But with Aurora, it's still vertical scaling, but a reboot is not required. That's what today's lab is all about. And then storage, right? With normal database, I start with 20 gigabit. Remember, we kind of give 20 gigabit, 40 gigabit, and all that. And anytime the database becomes full, I'll have to expand that size, right? Kind of stop and then add volumes to it and then expand on and on. I'll have to do all that, right? It also is going to require and reboot. But with Aurora, right, that's not the case. Aurora uses EFS like storage. Okay, EFS is auto scalable. It can automatically scale, right? We did a lab on EFS. So Aurora uses EFS like storage. So we don't have to like pre-provision the storage. Aurora automatically handles that. So Aurora automatically handles the scaling of CPU. Aurora automatically handles scaling of storage. So if you understand these two things, right, you have understood Aurora, 80% of what Aurora is. Okay. So that's the main difference between normal database and Aurora. And because of this, right, companies are moving to Aurora. You saw developers, they work with Aurora. You saw cloud engineers, application support engineers, infrastructure engineers, they work with Aurora because it kind of takes away the headache of scaling manually, intervening and scaling your database. If something that can be done automatic, let it do it the automatic way, leave it that way itself. Okay. And Aurora is good in uh, scaling CPU and storage automatically, so that's why most companies move to Aurora. They start with normal and then they move to Aurora. All right, so let's do this lab. So what are we going to test? We're going to test two things: scaling Aurora's CPU and scaling Aurora's storage. Fine. All right. So let's. create an database. Yeah, let's create a database. Let it be Aurora SQL compatible. It's full configuration. It can be dev test. All right, dev test. There are two types of Auroras available. Inside Aurora, there are two types based on scalability. One is provisioned, where it works like a normal database. You manually, give the size and you manually give the storage. Okay, manually give the size and manually give the storage. That's one type. The other one is serverless, where it the scaling is automated. Okay, the vertical scaling is automated. You kind of provide, yeah, you kind of provide the minimum CPU. Remember AutoScaling? We provide the minimum CPU and the maximum CPU, and it will scale by itself, okay, within this limit. So here I'm giving 2 and then I'm giving 4 here. Okay, that's my minimum Aurora CPU unit, and that's my maximum Aurora CPU unit. Fine. All right, database cluster identifier, master username is so and so, password is password1234. It's a weak password, that's fine. This is just the lab. Okay, I'm going to keep everything as defaults. Okay, I'm going to keep everything as defaults. Let's create the database. Okay, so that was easy, creating a database, and I'm waiting for my endpoint to come up so I can log in and access that database. All right, so let's go back to the document. What else is needed? So for me to test the database, we're not going to launch any big application today. We're only going to test how Aurora can vertically scale automatically and how Aurora can scale the storage automatically. Just the test, but we're not going to launch any application on top of it. Right. So for me to connect to the Aurora database, I need an EC2 instance. So let me go in here. I have something running already. North Virginia stopped. Okay, when did this happen? I didn't stop anything. That's fine. So let me start this instance. This is in North Virginia. My Aurora is in North Virginia as well. My database is getting created. Wonderful. All right. So my EC2 instance is in running state. Let me log in to my EC2 instance. Remember, we're not going to launch any application. We're only going to test those two features of Aurora through this lab. That's all. Right. So log in and then basically install a client in it, SQL client in it. Chances are that it's already installed from yesterday's lab. Yeah, it's installed from yesterday's lab. But if you're launching an EC2 for the first time, we might need to install it. Let's look at the version. MySQL version is available. Now, I'm also going to install Docker. Okay, Docker in this EC2 instance. I'll tell you why little later. Okay, uh, maybe I can tell it now. Sysbench is an software. Let's go here. What is Sysbench? Right. Sysbench is an testing tool. Okay, it is used to test the performance of CPU. Okay, CPU especially for database. Sysbench stands for system benchmarking tool. Excuse me. It's a benchmarking tool. Now that's not available as an installation software. Okay, you can't like download that software directly from the internet and install it. Okay, it's not available and compatible for installation. Okay, but it's available only in a Docker version. Okay, so that's why we're installing Docker first, and then we're installing an Docker container that has Sysbench already installed in it. What is Docker? What is container? We'll talk about that in the upcoming sessions when we talk about ECS, Elastic Container Service. That's an upcoming service, upcoming lab and session on that. So at that time we'll talk about Docker container, how it runs and all that stuff. But for now, let's just understand that Sysbench is not directly installable. It is available only through a Docker image or a Docker container service. Fine. So let me go back to my EC2 instance. I'm installing Docker as well. Install Docker. It's a small lab. I think I'll be done in another 10-15 minutes, and then maybe we can spend some 30 minutes you doing the lab. Okay, so I believe today we will be able to uh, do the lab. I mean, participants will be able to do the lab. Right, so Docker is installed. Is it installed? Let's try installing it again. It says it's installed. Good. Now let me start and enable Docker. Okay, that's done as well. Docker version. Check the Docker version. Okay, I have Docker version 25014 installed. Fine, let me give some permissions for this Docker user to kind of use um, some folders in this server. Okay, and now let me pull the Docker image, okay, from the internet. This is my Docker container. Okay, and then run the Docker container and check the version in the Docker container that I have pulled. Right, so it's pulling it from the internet. That's like running a small computer inside um, your existing VM. Okay, running a small miniature VM inside your existing VM. That's container. Okay, and what version is installed? Okay, just downloaded, right? I did not run it yet. Let's run it. Okay, the version is 1.017. Fine. Okay. Now, what do I have so far? I have an So I have an EC2 instance and I have an RDS Aurora. So from here, I'm going to connect to my Aurora, all right? And then I'm going to use and create a table maybe, okay, called load test. And then I'm going to create a table inside that called SB test one. Okay, I think it's called sysbench. Yeah, sysbench test one. And then I'm going to create a table. And then I'm going to, add some data to the table. Okay, let's do that. Okay, we need to connect to Aurora database. Go in here, take the Aurora endpoint. Take the Aurora endpoint, go to EC2. From here, log in. It's going to ask for password. Where's my password? Password is right here. I'm logged into Aurora. Okay. And then I'm going to create an table and, prepare um, the table, kind of create simply 5 lakh rows to it. Firstly, we're going to check or we are going to test the CPU auto scaling of Aurora. Okay, so that's the first test. The second test would be test the storage auto scaling of Aurora. Just 2 tests, and that's all. That's all. Right. Fine. So I'm connected, and then I'm creating an database and table in Aurora. Okay, that's done. Kind of exits. I should have not exited. That's fine. I should have. Oh, exit is needed. Yeah, we just created a table. And then from EC2, right? In EC2, I have a Docker installed. Inside Docker, I have sysbench running. In other words, my sysbench is running in a Docker image in my EC2. So I'm calling my sysbench and I'm interacting with Aurora and I'm creating an table size of 5 lakh rows. Okay. And then I'm adding some data to it. First, I'm creating 5 lakh rows and then I'm adding some data to those rows. This requires some editing, okay, because I need to provide here my Aurora host name, and then I need to provide the password. So password is already available, but I need to substitute this with my Aurora host name. So let me copy this. Go to yeah, go to here. Copy both the commands. Keep it ready. Substitute my Aurora writer endpoint. So go back to RDS. This is my Aurora writer endpoint. My Aurora writer endpoint is this. Okay. Okay. So this is my Aurora writer endpoint. Copy that. Put here. Substitute the Aurora writer endpoint. Okay. It says table already exists. That's fine. A table is already available, and in that I'm creating a table size with 5 lakh rows. Okay. So that's creating the table, and then I'm putting in some data in that table now. Okay. So come back here, let it run. Okay. In the meantime, I'll maybe walk you through on what we just did. Okay. So what we did is we created an table, with these many rows, and then we are, right, OLTP read and write. We are randomly, randomly reading the content from those 5 lakh rows, randomly writing content to that 5 lakh rows, all right, randomly deleting content to that 5 lakh rows. Okay, so that's like a big transaction. 5 lakh rows, going crazy, doing all the reads and writes randomly. So it's like, we having an 5 lakh user database, 5 lakh users trying to access the application all at the same time. That's like peak load simulation, right? Uh, Amazon equivalent, peak load simulation. Okay, so that's the kind of peak load simulation we've given to our database right now. So it's going through it. Okay, it's reading, it's writing, it's deleting, it's updating, on and on. Okay, so kind of giving that load. Let it run. Let's go to Aurora. We are here to test the what? Scaling of Aurora, right? And during load, it's supposed to scale, right? Auto scaling, that's what it does. And you remember for Aurora, we've given low CPU and high CPU. So during low load, it's supposed to run that low load CPU utilization, and during high load, it's supposed to kind of scale itself and use more CPU, right? And that's what it is doing right now. Let's test that. So let's observe the CPU scaling in Aurora. Let's go to RDS database write instance monitoring and look for Aurora CPU utilization. Okay, so go to database monitoring, kind of search for Aurora CPU utilization. Okay, maximize that. Okay, 1 second, 1 hour, local time. Okay, so what just happened? By 10 o'clock or so, this is local time, Indian time. Yeah. So by 10 o'clock, 10:01 or so, Aurora was running on 50% workload. Okay. And we started, we created the table, and now by maybe 10, this is 10:02, right? So between 10 and 10:02, that's 10:01. Okay. 10 hour, 10 o'clock, 1 minute. By exactly that time, right? We kind of gave more load to Aurora. So Aurora's utilization is now running at 100 percentage right now. Okay. Behind the scenes, remember we gave some capacity, right? Serverless capacity to use. So let's open that. Local time zone, 1 hour, 1 second. Okay. So the minimum was 2, right? Minimum CPU was 2 and maximum was 4. So during that, one moment, please. Local time zone. Okay. Okay. Sorry. My mouse is behaving crazy. Okay. Stay calm. All right. So by this is serverless database capacity, right? Remember, we gave 2 as minimum and 4 as maximum. So during normal load, right, it was using 2 virtual CPU. And by 10:01, right, we gave load. At that time, the CPU kind of scaled up to 4. You see, what metric are we looking at? We're looking at serverless database capacity metric. So that metric kind of scale up to 4. Now Aurora is using 4 CPU, kind of scaled up automatically behind the scenes. That's what this dashboard shows. Once after the test is over, right, it's going to run for like 5 minutes or 10 minutes. Once after the test is over, Aurora is going to scale down to 2 virtual CPU. So this is Aurora CPU scaling. Okay. We're trying to understand Aurora CPU scaling through the monitoring dashboard. okay, by giving more load and trying to understand the CPU it's using during normal condition and the CPU it's using during high load condition. Fine. So let's go back here and the sysbench has done its testing. So what did it do? It kind of ran for how many minutes? We'll kind of look into it. It ran these many reads. This is what 64,000, 29 lakh, 64,000 reads, and then 7 lakh, 2,000 some change writes, and there were other actions as well. 5 lakh 66,000 other actions. So on a total, it kind of ran 42, that's lakh, right? Yeah. So 42 lakh 32,000 actions. Okay. It did that many actions. And the um, total transaction is in a transaction would include read, write, delete, on and on. So total transaction were 2 lakh 10,000 some change transactions. Okay. And it did all that within 5 minutes. Okay. And it kind of created these many transactions inside the database. That's like heavy load. Okay. Heavy load to the database for the past 5 minutes. And based on the load, Aurora kind of scaled itself. That's what we saw through the monitoring dashboard. So this is CPU scaling. Okay. Next, we're going to understand about storage scaling. Any questions anyone have on CPU scaling before we try to understand storage scaling? Any questions, anyone? All right, fine. Let's try to understand storage scaling. It's a simple lab. We can like do it in 10, 15 minutes. So today we'll do that lab. Fine. Let's understand storage scaling. Recall EBS and EFS. EBS, we provision 20 gigabit and then we provision more, right? It kind of required manual intervention. But with EFS, it did not require any manual intervention. We kind of attached the EFS and EFS was storing automatically. Aurora storage, it uses an EFS like storage. Okay, so Aurora storage is like EFS like storage. It's a cluster volume storage. So, you put some data and end of the month you pay only for the data, not for the storage provision. You put more data that month, we'll be paying more. We put less data that month, we'll be paying less. So, Aurora storage is auto scalable. It can expand and it can shrink by itself. Okay, storage, we're talking about this. Let's see, or let's test Aurora storage, part 8. So log into Aurora, yeah, and then create a table called big table. And then we're going to insert 1 million rows to it. That's equivalent to 1 gigabit. Okay. And then we're going to create multiple we're going to create a copy of that table, inside that database. By that, we will be scaling the database storage and Aurora will automatically scale. That's what this lab is about. Okay. In other words, what is that we're going to do? There's going to be an EC2 instance. This is my Aurora, right? I'm going to create a database. Yeah, this is my Aurora. This is my big table. Sorry, this is my database called as load test. So inside that database, I'm going to create a table called as big table. This is going to be 1 gigabit. Okay. So, I mean, just like that, Aurora will absorb this storage and it will create a table and will let me create a table. It will allow me to use 1 gigabit of storage. Okay, I'm going to, after this, right, we're testing storage, right? So we'll have to randomly create more data to take up more storage, right? So I'm going to copy this table and rename it, maybe call it as big table 1. So that way I'll be using 2 gigabit, 1 gigabit plus another 1 gigabit. That will make it 2 gigabit. And then I'm going to copy another one, and then I'm going to copy another one. It's going to make it a total of 4 gigabit. Remember, we are here to test the Aurora's storage auto scaling. So I don't have to pre-provision. I can keep on creating table after table after table. I can keep on adding 1 gigabit after 1 gigabit after 1 gigabit. Aurora is going to, absorb and, let me use that space. Okay. Without me pre-provisioning it. That is Aurora's storage auto scaling. Fine. So let me log into Aurora. Log into Aurora. And the password is, it's here. Password is here. Okay. And then I'm going to use a table called load test. Logged in. I'm using a database called load test that's created. And then I'm going to insert 1 million rows to it. It's going to take some time. I'm installing 1 million rows to it. Okay. So that's done. Took some time. All right. Now I created a table called as big table and put some data in it. Yeah. Now let's create, make a copy, right? Make a copy of big table and call it big table 2, and make a copy of big table and another copy of big table and make it big table 3. Okay. So by that, I'm kind of scaling the storage. Okay. And log into Aurora. Password is available here. Okay. Use table, use load test, and then scale the table, or maybe copy, uh, make multiple copies. Okay. Big table, make a copy, call it big table 2. Big table, make a copy and call it big table 3. Okay. So all together, now the storage size would have increased, right? It's 1 gigabit. Okay, big table 2 and big table 3 has not increased. Maybe that's going to take some time. Okay, let's create big table 4 and big table 5. Okay. So basically making a copy of big table and calling it big table 4 and big table 5. Fine. Let's see. Let's verify the size of the database. It has grown up to 3 gigabit. Okay, so initially it was 1 gigabit. The database did not complain. It took 1 gigabit as it is, and then I kind of created multiple tables, 1 gigabit each. Now it grew up to 3 gigabit. Database did not complain because it's running on a system like EFS behind the scenes. It will automatically absorb that, and it will grow by itself. So this kind of Aurora, right? Aurora takes all my management, uh, offloads all the management task from me. It's automatically managed by Amazon, right? So the CPU scaling and the storage scaling, I really don't need to worry about it. Amazon will take care of it by itself. And because of these two important features, right, companies move to Aurora because they don't have to worry about CPU scaling. They don't have to worry about storage scaling. And database being an important component in an application, uh, the companies and the projects, right, they like not to worry about the database, CPU scaling and storage scaling. And that's why companies like Aurora and they kind of migrate to Aurora or they use Aurora. And I showed you in Naukri why companies, I mean, a different job and role positions that require Aurora skill. Fine, that's all I had. Any questions before we get into the lab? Any questions, anyone? Okay. Oh, all right. So